variance, how should we be able to define it? Your first guess might be to look at the random variable x minus ex, and we want to see how far away it is from 0. So your first guess could be, let's just take expectation of this random variable itself. This will tell us how far away we are from expectation. But again, some thought shows that here the contributions might cancel. So if x is more than ex by a big amount, and if x is smaller than ex by a big amount, they can cancel. So this quantity should in some sense always be positive. This suggests that we should look at this expectation. So mod of x minus ex measures how far away we are from ex and penalizes both. Even if we are positively away from ex, we are more than ex, or if we are much smaller than ex. In both cases, this expectation is penalized, in the sense it's high. The only problem here is that the absolute value function is not a very nice function. It is not continuous and so on. So the quantity we actually measure is very similar, but just square of this. So the variance is defined as the expectation of x minus ex whole square. How far away x is from ex, we notice that and square it to keep it positive. We can simplify this expression to make a simple formula for variance of x. Just expand it as a plus b whole square. This becomes 2x ex minus expectation of x whole square. So notice this is expectation of x whole square. So the first quantity by the union of expectation is expected value of x square minus 2. Now it's a tricky but actually a trivial question. What is expected value of x times ex? Remember, ex is a constant. It is same throughout my random experiment. So expectation of x could be taken out. And then I have another value of expectation of x. Minus, similarly, expectation of x whole square is also a constant. So it stays the same under expectation. This was a plus. So the entire thing gives us expectation of x square minus expectation of x whole square. This is known as the variance of x. You notice that we squared the quantity. So sometimes taking a square root of this quantity is considered better. This is called the standard deviation and is generally represented by sigma. Sigma of x is nothing but the variance of x. Substituting the formula, this is square root of e to the x square minus e of x whole square. This is called the variance. Let's take a small example. What is the standard deviation of Bernoulli random variable? You remember what a Bernoulli random variable is? It's just a coin toss where we get a head with probability p, or we get value 1 with probability p and 0 with probability 1 minus p. So we just have to calculate these two quantities. Expectation of x square, you can see that will come out to be p. You can calculate it yourself, and expectation of x was p, so expectation of x square will become p square. So the sigma for the Bernoulli random variable is square root of p1 minus p. This suggests a simple exercise which again you should think about. When is this maximum? When I say when, I mean for what p? For what value of p, for what kind of coin, this standard deviation is the max. And you have to check that does it agree with your intuition? Remember how we defined variance and similarly standard deviation? So does it make sense that for that P, this variance or standard deviation should be highest? We will just see one more inequality and finish this lecture. That is called Chebyshev's inequality. It is pretty simple, and we just apply Markov's inequality to a different random variable, which is x minus e of x. Say square or this, it doesn't matter. So we have seen that capital X, alpha x, x plus y, x plus a, all these are random variables. So now call this as a new random variable x minus e of x. Ex is a constant, x minus e of x whole square. Even this is a random variable. So by Markov's inequality, probability that y is less than a is bounded by, it should be y is greater than a is bounded by expected value of y by a. And now substituting y to be this quantity, you will get Chebyshev's inequality, which says probability of x minus ex greater than equal to a. So we are very far away from ex, that is bounded by variance of x divided by a square for a. So whatever be x, remember y is always a positive random variable. So we can apply Markov's inequality, and this will give this. A complete proof is an assignment. So we saw two very basic inequalities today. These will help us to give law of large numbers, Chernoff bounds, things which are known to formalize the concept what is expectation. Again, expectation is the value which you should get if you take the average of many repetitions of x. And this we will formalize in the next lecture.